Okay, so I want to point out that just a couple of trig rules here. So if I have a force at some angle, um, I can break it up into x and y components, and I can use trig basically and treat this original force like the hypotenuse of a triangle, and I can find x and y components. Okay, why do I want to do that? Why does that help me? Say, for example, I have a bunch of random forces acting on something, and they're all at, like some odd angles to each other or something. Um, for me to be able to add those forces together, I want to break everything up into x and y components, basically, so that they would be on the same coordinate system, right? So like if these are my forces, like I would break this one up into y and x. I would break this one up into, like x and y. And then I would rewrite all of my forces, as the x and y components of those forces, right? So I'd have this big one over here and this little one. And then when I do things where I do sum of forces in the x and sum of forces in the y, it makes it easier for me, right? So then I would have like, this chunk here. Maybe I'll call this like F1, F2, F3, F4, F5. Just, this wouldn't be how you would necessarily label them in your own problem, but so I have like F1, negative F1 plus F2 plus F3 in the x direction. And then in the y direction, I would have like F4 minus F5, right? Choosing the sign convention based on where they're pointing. So F4 is up, so it's positive. F5 is pointing down, so it's negative. So I would just pick this to be, positive y and this to be positive x. So this makes things easier when we have a lot of forces at kind of more complicated angles. So trig ends up being really important when we're resolving things in our physics problems. So let's talk about how we would use trig and break stuff up here. So here's the y. Let's talk about how. Okay, so f of y, so this y piece, when we have the side that's across from the angle, we're going to take the magnitude of the hypotenuse. So just like, that the magnitude of f, and then we have sine of theta. Okay. For the f of x piece, if it is on the adjacent side, so it's next to the angle, right? Next to that angle, it's going to be the magnitude of f cosine of theta. Okay? All right, and then one other piece too. So we know also we can find tangent of theta by taking the side across from the angle. So the side across from the angle divided by the side adjacent to the angle. So it'd be f of y over f of x. And that could be useful if you have two forces, right? And you want to, or two sides of the triangle, and you're trying to find an angle, okay? So then I could just do like inverse tangent of fy over f of x to get my theta. Okay, so if any of these pieces are something that you find unfamiliar and you feel like you struggle with breaking up forces in this way, please put this on a cheat sheet before the exam. These trig rules are going to be incredibly crucial. Any problem where you have a bunch of different forces acting on an object and you need to break them up based on the angles and resolve them, you're going to need to use trig for problems like that. So please put this on your cheat sheet if you feel a little bit uncomfortable with some of these concepts. It will be very, very important for all of your physics problems.